Welcome to BHARGAV SUBS. Now, previously we discussed the information regarding method of image. So like how the steps we will follow in that and what are the main steps, we discussed some steps. Okay. Now, for applying method of images concept to solving problem, or like I told you, it was a trick. It was a trick to solve the problem. Like you are keeping a imaginary charge in the region of conducting surface. By that imaginary concept, you will apply some mathematical tricks to get the potential value or electric field value. Similarly, if you want to apply method of images, two conditions you must have to apply there. What are the two conditions? The image charge must be present at the conducting region. See, actually there is a real charge, one real charge on the conducting like on the surface, you know, and also that conducting surface also is a imaginary. You are imaginarily drawing right there. So with this, there is a charge distribution on that conducting surface. By using that real charge, it is difficult to calculate the process. So that's the reason you have to keep the imaginary charge. With that imaginary charge, that there is a redistribution in that conducting sphere, so that the potential is zero. Potential is constant. Okay. Potential is constant on the conducting sphere. Potential is zero when conducting surface is grounded. When conducting surface is grounded, the potential will be zero. The potential remains constant always. Potential remains constant always. So like you have to adjust that conducting region. In the conducting region, you have to imagine a imaginary charge. Then only you can able to replace the conducting surface over the under the charge, so that there is a charge induced. Due to that charge, there is a charge induced on that surface and the potential remains constant. This is the first condition. Coming to the second condition. What is the second condition? I already told you the point. The image charge must be located at the conducting surface. Potential is zero or constant. I told you, like if this is a conducting, if it is a grounded, then V is equal to 0, or if it is not grounded, then potential remains constant. And also this is equivalent to the boundary conditions that says tangential component vanishes. Generally there are two components. One is normal component, which is perpendicular, and another one is tangential component. Tangential component vanishes means it is parallel component. Normal component means it is perpendicular component. Tangential component vanishes on the surface of the perfect electric conductor. So if you want to satisfy the given equation, like given potential with boundary condition, tangential component field should be vanished, because what, if the tangential component is present, due to the charge distribution, there is a creation of electric field inside. But for a perfect electric conductor, we are considering a perfect electric conductor. For the perfect electric conductor, E is 0. There is no electric field. But if you consider tangential component there, tangential component of electric field there is a creation of electric field. There is a creation of charges there. Okay, due to the parallel component. So if it is a normal component, you have to consider only normal component in this case. Means what? By considering tangential component, you will get a contradiction. What is the contradiction? Before solving the problem, you will assume that perfect conductor is a equilibrium. It is in equilibrium. Okay, equilibrium means what? There is no net motion of charges. So that if you place the tangential component, there is a creation of free charges inside. The perfect electric conductor. So that there is a creation of electric field due to the free charges. But if you remove this, if you place only normal component or perpendicular component, then you can get there is no free charges inside it was present, then you can get electric field 0. These are the two conditions you have to apply before going into the applying the method of images.